Okay, there are some questions related to chain rule. Okay, let's take a look. Thanks, In, for the questions. Really good questions. First one is y is equal to x squared square root of 4x minus 5. Okay, well, here's the thing. Find the y prime, of course. Let's make it zoom in. Well, the one thing about this is the big picture, you have to see it. It's product rule, obviously, right? This is because there's one thing and another factor, two factors, and we need to multiply them together. But in order to multiply them, you have to apply the what? Product rule, okay? So first I'm gonna rewrite this and keep your options open, rewriting options open. I'm gonna rewrite the radical with the 1/2 power. You may ask why, because then it will be easy for me to apply the chain rule. Okay, so what I'm going to do first, I'm just here, the first one is the x squared, and the first one's derivative is what? 2x, and the second one is what? 4x minus 5 to the 1/2 power, and the second one's derivative, actually let me move these a little bit farther away from that. The one's derivative 2x, thanks to Cynthia for this idea. Well, there are many ways to design it. That's just Cynthia suggested that, you know, there are some professors that are doing this way, and it's kind of catchy and students like it. So yeah, I don't mind. Yeah, we can apply. So that's the chain rule. Okay. I don't know if you follow it, but let me show you the derivative of the 4x minus 5 to the 1/2 powers derivative. The extended power rule is kind of like onion for you coming from outside the inner side. So first you take care of the 1/2 part. So that will come in front of it, and you will decrease the exponent by 1. Do not touch inside. The reason this is negative 1/2 because this is 1/2 minus 1 times 4. Where is that 4 coming from? Inside the derivative. Okay. That's the chain rule. Make sure you watch the chain rule videos, okay? This is not a lecture. This is just working out the problem. I make assumption right now you'll know how to take the derivative by using the chain rule. All righty. So let's simplify that. Of course, let's not leave it like this. What is that going to be? 2 prime, because 1/2 and 4x. Oh, that's not 4x. That's 4. My bad. Shame on me. That's going to be 2 4x minus 5 to the negative 1/2. Okay. So actually, let's organize them in a little bit better way. Let's erase them. Let's erase this one. I'm just going to write the simplified version of it. So 2 4x minus 5 to the negative 1/2 power. All righty. So what's going to be here is just that's how it is, like 1 times 2 prime, and then plus 2 times 1 prime. I don't know, just I think that's how, maybe I misunderstood, but that's how Cynthia suggested to do it. Sorry, Cynthia, if you're watching this video, if I'm doing something wrong, please forgive me. It's my fault, not yours, okay? Anyway, let's calculate it. Y prime, then it's going to be the x squared times the derivative of the second one, which is the 2 4x minus 5 to the negative 1/2 power, plus the 4x minus 5 to the 1/2 power times 2x. That's it. You're technically done with the calculus right now. That's where the calculus is over. Okay, so the rest of it you just can simplify. So what you're going to do here, factor out the GCF, greatest common factor. What's the greatest common factor? Well, remember, I always say that, you know, let's say a to the 5th and a squared And what's the greatest common factor here? A square, right? Why? Because you look at the exponents and you aiming for the smallest exponent with the same basis, of course. Well, you're gonna do the same mentality in here. When you look at this, you know, the first term and the second term, and obviously 2x is the part of the GCF because there are 2x in here, there's 2 and one of these x in here, okay? So I'm gonna erase those. And also 4x minus 5 to the what power? Negative 1/2 power. Well, if you write it this way, you notice that this is the smallest exponent, so I'm gonna factor that. So you're gonna factor that negative 1/2 out of this from this exponent. So the greatest common factor is 2x, 4x minus 5 to the negative 1/2 power. What's left inside the parentheses from the first term is just x. From the second term, what's left is 4x minus 5. That's it. I bet you just confused here. Let me show you one more time. This part is, remember, like one more time, let me go this factorization. You factor that a square, right? Okay, you know that greatest common factor. So what's left over inside the parentheses? A cubed plus 1. How you know this is a cubed plus? Why is this a cubed? What did you do? Well, let me tell you what you did. Existent exponent minus what you factor in out. And this is exactly what's happening. Existing exponent minus I am factoring out the greatest common factor. That's it. A 1/2 minus negative 1/2 is just the 1 power, first power right there. Therefore, if I fix this, that's going to be y prime 2x 4x minus 5 to the negative 1/2 power. Let me fix this in parentheses. That's going to be 5x minus 5. Okay. And maybe I can factor that 5 in here. So that's going to be 10x x minus 1, 4x minus 5. That's it. I did maybe a little fast. Again, I factored that 5 in here, 5 and 2 together, 10. And you have to always write with the positive exponent, okay? And remember, the original problem contains a radical, so look at my answer with the same fashion. Also, I contain a radical, okay? I mean, personally, if you write it this way, and that's why you are so lucky that I am collecting your exams. You have to scan it, make a PDF and submit it, because in case of conflicting with the MyMathLab, that's where I come in and give you partial credit or maybe a full credit. You never know. So either or the same answer to me, okay? I'm not sure for the MyMathLab. All right, another question is, y 4x minus 4 to the 5th power and 1 minus x to the 5th power. So thanks again, In, for asking that question. Again, this is big picture is what? The product rule. And what you need to do, well, when you take the product rule, you have a chain rule inside. So shall we do the same strategy? Like first one is what? 4x minus 4 to the 5th power. What's the first one's derivative? It's going to be 5, comes in front of it, decrease the exponent by 1, 4 times the inside the derivative, which is 4. So if you simplify that, that's going to be what? 20 x to the 4th power. Yeah. Okay. Second one is 1 minus x to the 5th power, and that's derivative is 5 comes in front of it, negative 5x to the 4th. Okay. And let me simplify that. That's going to be what? Negative 25 x to the fourth, 1 minus x to the fifth in the parentheses fourth power. Is that right? Let's double check. Always double check. I mean, even sometimes I make mistakes. So it happens. I am double checking. Everything's good. So again, if you don't understand that, just apply the product rule, okay? So what's the y prime gonna be? Y prime will be the first one, which is what? The 4x minus 4 to the fifth power times the second one, which is negative 25 x to the fourth, 1 minus x to the fifth to the fourth power, plus the second one, x to the fifth power, times 24x minus 4 to the fourth power. Okay, that's multiplication. Wow, nice, huh? Well, again, very big, massive term, and they have something common. What is that common thing? Well, let's look at the number-wise first. Actually, let me write this one in here. Erase this parenthesis just to show that that's negative 25. Well, numerical part, I don't know if you guys see it. The 5 is the greatest common factor. Or I don't know, if you want to factor that negative 5, feel free. You can also factor that negative 5, okay? So second part is that's kind of long problem. The reason I'm looking at it in the MyMathLab, it doesn't have to be one way. You know, you can factor out, like I said, negative 5 in here. You're still gonna get the same answer. How about these? 4x minus 4 in the parentheses to the fifth power and 4x minus 4 in the parentheses to the fourth power. So which one? The greatest common factor. I'm going to aim for the smallest exponent, right? 4x minus 4 to the fourth power. That is right. Yes. All right. How about the next one, which is 1 minus x to the fifth to the fourth power and fifth power in here. And I'm going to pick the fourth power. Yes, that's right. Fourth power. So if I factor that 4x minus 4 to the fourth and 1 minus x to the fifth in the parentheses to the fourth power. So what's left from the first term? The 5 is gone, negative 5 left. If this is negative 5 times 5, right? So negative 5 left, x to the fourth left, and what else? 4x minus 4. Because you factor not 4x minus 4 to the fourth power, you have fifth power in here, so one of them left. And from the second term, plus, you factor that 5, 4 left, because this is 5 times 4, you take the 5 out, and you also factor that 1 minus x to the fifth to the fourth power. So what's left in here? 1 minus x to the fifth. And you factor this whole part out, so that's gone. Look, one more time, ladies and gentlemen, this is where the calculus is over, this step. Rest of it is algebra. It's all about the simplification, okay? You can take the derivative, you can get this answer right there in this step. You cannot leave your answer like that, okay? You got to simplify. That's your responsibility too, you know? So let's take a look. Distribute this one back. That's negative 20x to the fifth plus 20x to the fourth. Distribute this one, plus 4 minus 4x to the fifth. Okay. So add the like terms if there is any in here, which is what? Negative 24x to the fifth plus 20x to the fourth plus 4. And the other part, just bring him in here. It's pretty ugly, tedious, And that's what makes it beautiful. Can you factor that? No, I mean, no, you can't. I mean, maybe you can, but I'm not gonna bother. You can't, it's not nice. If that's degree 2 or something, you can maybe factor that things. Is that good? Okay. And again, there's a, make sure you look at my suggestion when you're doing problem like that, look at the view and example first. How they answer, how they want the answer at the end. Sometimes you simplify, you go in there, but it's not exactly the similar format. So it may mark it wrong, okay? In ask another problem, it's the similar one, actually. 5x minus 1 cube, 2 minus x to the 4th cube. Again, try this one, pause the video right now, try it. I'm gonna work it out, of course. So let's say this is 1, this is 2. The 1 is 5x minus 1 cube, so 1's prime is what? 3, 5x minus 1 squared times 5. Inside the derivative, one more time. Why this is 5? Inside the parentheses derivative, okay? Likewise, 2 is 2 minus x to the 4th in the parentheses cube. 2 prime is 3, 2 minus x to the 4th square minus 4x cube. Where is that negative 4x cube coming from? The inside the parentheses derivative. One more time. Okay. Now we'll do the same thing. So that's going to be what? 5x minus 1 cube times this guy, which is what? Negative 12x cube, 2 minus x to the 4th square, plus, oof, that's a lot. 2 minus x to the 4th cube, this guy, times the 1 prime, which is 15, 5x minus 1 in the parentheses square. You with me? Yeah. Now, again, same thing. I think this is the problem when you did the first one wrong. It gives you the different numbers. Greatest common factor. Well, 12 and 15. Isn't that 3? Yeah. 5x minus 1 cube. Oops, not cube. 5x minus 1 cube, 5x minus 1 square. Which one is going to be? It's going to be square. And, sorry, 2 minus x to the 4th in the parentheses square, 2 minus x to the 4th in the parentheses cube. Which one is going to be? It's going to be square. Okay, so therefore, if I factor that 3, 5x minus 1 in the parentheses square and 2 minus x to the 4th in the parentheses square, what's left here is from the first term, 5x minus 1 times negative 4x plus from the second term 2 minus x to the 4th times 5. Sorry about that, it's just kind of under the GCF, but I don't know if you can see it clearly. So let's simplify it. Don't touch here, this is going to stay as it is. And let's fix here. So that will be what? Negative 20x squared positive 4x plus 10 minus 5x to the 4th. Okay, so minus 5x to the 4th minus 20x squared plus 4x plus 10. Is there any greatest common factor here? Better not. You cannot. Can you factor without this? No, you cannot. So that's the answer. You feel bad? Don't. That's the chain rule. Actually, in the chapter 2, you are not going to see that crazy differentiations that much. Okay, I think that's it. Let me know if you guys have more questions.